Hi everyone. Today we're going to study representing relations using matrices. A relation between finite sets can be represented using a matrix with elements 1 or 0. Suppose that R is a relation from set A with elements a sub 1, a sub 2 up to a sub n, to set B with elements b sub 1, b sub 2 up to b sub n. The elements of A and B have been listed in a particular but arbitrary order. When A equals B, we use the same order of elements for both the sets. The relation R can be represented by the matrix capital M sub R with elements small m sub ij such that m sub ij equals 1 if the ordered pair a sub I, comma, b sub j is an element of the relation R, or the value is 0 if the ordered pair a sub I, b sub j is not an element of R. Let us see example 1. Suppose that set A equals 1, 2, and 3, and set B equals 1 and 2. Let R be the relation from A to B containing the ordered pairs of the form A, B if A is greater than B. Write the matrix corresponding to the relation R. Set A has 3 elements while set B has 2 elements. Thus, the M sub R must be 3 by 2 matrix. We can write a blank matrix in here. Let us now write the respective ordered pairs. Starting with the first element of A, which is 1, we will take this as the A, while the elements of set B to be the variable B. So we have here 1, 1 and 1, 2. With respect to the condition that A must be greater than B, for the 1, 1, we see that 1 is equal to 1, so here we write 0. For the 1, 2, 1 is less than 2, so we write here 0. For the next ordered pairs, we use the second element of A, which is 2. So the ordered pairs are 2, 1 and 2, 2. For 2, 1, 2 is greater than 1, so we write here 1. For 2, 2, they are equal, so we write here 0. For the next ordered pair, we will use the next element of set A, which is 3. The ordered pairs corresponding to this will be 3, 1 and 3, 2. We can see in 3, 1 that 3 is greater than 1, so we write here 1. In 3, 2, 3 is greater than 2, so we write here 1. This is now the matrix corresponding to the relation. This is the final answer. Example 2. Suppose that set A equals a sub 1, a sub 2, and a sub 3, and set B equals b sub 1, b sub 2, b sub 3, b sub 4, and b sub 5. Write the relation R as a set of ordered pairs whose matrix is given by the matrix here. For our solution, we shall write the corresponding ordered pairs with one value on the matrix. The ordered pairs are here. For the first row, this number 1 here corresponds to a sub 1, b sub 2. In the second row, this number 1 corresponds to a sub 2, b sub 1. Another number 1 is here that corresponds to a sub 2, b sub 3. This number 1 corresponds to a sub 2, b sub 4. In the third row, this number 1 corresponds to a sub 3, b sub 1. This number 1 here corresponds to a sub 3, b sub 3. And this number 1 is a sub 3, b sub 5. This is the final answer. There are notes here that we need to consider. Number 1, if the diagonal elements of M sub r with elements a sub ij are all equal to 1, then the relation R is reflexive. Second, if M sub r equals the transpose of M sub r, then R is symmetric. Third, this M sub r union S equals M sub r or M sub S, or this is also called the join of the two matrices. Number 4, the M of R intersect S. This is equal to M sub R and M sub S. This symbol is also called the meet of the matrices. Number 5, the matrix of R composition S. This is equal to M sub R Boolean product with M sub S. Number 6, the M sub R raised to n is equal to the matrix M sub R, and this matrix is raised to n power. Number 7, the M sub R inverse is equal to the transpose of M sub R. Number 8, the M sub R complement equals 0 if A sub ij equals 1, or the value is 1 if A sub ij equals 0, obtained from the M sub R. Today, we're going to study representing relations using Digraph. An important way of representing a relation is by using a pictorial representation. Each element of the set is represented by a point, and each ordered pair is represented using an arc with direction, indicated by arrow. These pictorial representations of a relation on a finite set is called directed graph or digraph. Let us see example 1. Draw the digraph of the relation. This is the relation R equals from ordered pair 1, 1 up to 4, 4, defined on this set with elements 1, 2, 3, and 4. For our solution, let us draw 4 points here. Let us assign the elements of the set to each of the points. We can write the number 1 here or here, depending on where we want to put it. For this example, let us write this point to be 1, this is point 2, point 3, and point 4. Let us draw now the digraph, starting with the first ordered pair 1, 1. Let us draw an arrow from point 1 going to point 1. So that will be a loop that looks like this. Next is the ordered pair 1, 2. Let us draw an arrow from point 1 to point 2. Here is the arrow. For the 1, 3, this is the arrow. For 1, 4, this is now the arrow. For our 2, 2, we're going to draw a loop on number 2. For the 2, 4, let us draw an arrow from point 2 going to point 4. For 3, 3, this is another loop on the point 3. Then the ordered pair 4, 4 represents a loop on the point 4. This is now the final answer. Example 2. Find the ordered pairs of the relation represented by the graph shown below, where R is defined on the set A with elements A, B, C, and D. For our solution, let's begin with the point A. Let us identify all arrows that goes out from point A going to another point. The first arrow is here, and we can see that this is from point A going to point B. That's why we write here AB. Another arrow from A is this, from A going to D. So we write here AD. There are no more arrows that goes out from A. Let's go now to point B. The same thing that we should do. Let us identify all arrows that goes out from B going to another point. The first arrow that we will consider is the loop, and this is now represented by BB. Next is this arrow here from point B going to point D. So we write the ordered pair BD. There are no more arrows that goes out from B. Let us proceed with the point C. Let us identify all arrows that goes out from point C. The first arrow is here. It is an arrow from point C going to point A. So we write here CA. Another arrow is this, from point C going to B. So we write the ordered pair CB. There are no more arrows that goes out from C. Let us now proceed with point D. Let us identify all arrows that goes from point D to another point. I can see here that there is only one arrow, and this is the arrow from point D going to point B. So we write here the ordered pair DB. So we have now here the relation, and this is the final answer. I hope you learned something from this video. See you again next time.